They do. They release energy on a scale that is genuinely hard to put into human terms. A single strong solar flare can release the energy equivalent of billions of hydrogen bombs in minutes. That flare travels to Earth in about 8 minutes, at the speed of light, and it can degrade radio communications and GPS accuracy on the sunlit side of the planet almost instantly. But the flare isn't actually the part that keeps space weather forecasters up at night. The flare is the flash. The real threat follows behind it, slower, heavier, and far more destructive: the coronal mass ejection. That's 1 billion tons of magnetized solar plasma, launched outward at speeds that can exceed 2 million miles per hour. It takes 1 to 3 days to reach Earth. And when it does, if its magnetic orientation lines up the wrong way against our planet's own magnetic field, it doesn't just brush past us. It couples with our magnetosphere and dumps enormous electrical current into the upper atmosphere. That is where this stops being an astronomy story and starts being an infrastructure story. Here's the part that connects directly back to your house. When a coronal mass ejection slams into Earth's magnetic field, it induces what's called a geomagnetically induced current. A slow, powerful electrical current that doesn't stay in the sky. It runs straight down through the Earth itself and finds the longest conductors it can: high-voltage transmission lines, pipelines, railway signaling systems, and transformers, the giant, custom-built, multi-ton pieces of equipment that step voltage up and down across the power grid, the ones that can take 12 to 18 months to manufacture and replace if they're damaged badly enough. Now, bring that back to the declining phase of solar cycle 25. The historical precedent scientists keep pointing to is not this cycle's twin. It's solar cycle 23. Cycle 23 peaked around 2001 strong, but unremarkable by historical standards. Then, in October and November of 2003, 2 full years into its decline, the Sun produced a sequence of eruptions so intense they earned their own name in the public record: the Halloween storms. One flare during that stretch was so powerful it overloaded the sensors designed to measure it, and had to be extrapolated to somewhere around x28 on the flare scale, nearly 3 times stronger than the strongest flare recorded during this entire current cycle. During those storms, a transformer failed in Sweden. Tens of thousands lost power in a matter of seconds. Airlines rerouted polar flights to avoid radiation exposure and communication blackouts near the poles. Satellite operators lost track of spacecraft entirely for stretches of time, because the atmosphere itself had swollen from the energy input, dragging on orbits like an invisible headwind. That happened during a decline, not a peak. And here's the number that should genuinely unsettle you. The strongest known geomagnetic event in the era of electrified civilization, the Carrington event of 1859, produced auroras visible as far south as Cuba and the Caribbean, and induced currents strong enough to set telegraph paper on fire in a world that had almost none of the electrical infrastructure we depend on today. Researchers who model what a Carrington-scale event would do to a modern, fully interconnected power grid have arrived at loss estimates in the hundreds of billions of dollars, with some regional blackouts potentially lasting not hours, but months, because of exactly the transformer replacement bottleneck we just talked about. That is not science fiction. That is a risk assessment sitting inside government and utility planning documents right now. So let's pause and do the thing this channel always does: separate the hype from the real concern, because both exist here, and they are not the same thing. The hyped version says the Sun is that this cycle is somehow historically extreme, that we're overdue for a civilization-ending solar apocalypse timed to some cosmic countdown. That version is exaggerated. Solar cycle 25, in raw sunspot numbers, is a moderately active cycle, stronger than the unusually weak cycle 24 before it, but not off the charts compared to the long historical record. The Sun is not malfunctioning. It's doing what it has done for billions of years. The real concern is quieter and, honestly, more unsettling than the hyped version, because it's not about the Sun getting scarier. It's about us getting more exposed. Here is the single most important thing to understand about why astronomers are actually worried. The danger isn't rising because the sun changed. The danger is rising because everything we've built since the last truly severe solar storm has made us more vulnerable to the same event repeating. Think about what's different now compared to 2003, let alone 1859. GPS timing signals now synchronize financial trading systems, cellular networks, and power grid switching stations down to the microsecond. All of it degraded or lost during severe geomagnetic activity. Low Earth orbit is now crowded with tens of thousands of active satellites, many of them flying in the exact altitude band where atmospheric drag spikes hardest during geomagnetic storms. In February 2022, a moderate, not even severe geomagnetic storm caused the atmosphere to expand and drag down as many as 40 freshly launched satellites within days, destroying them before they ever reached operational orbit. That was a minor storm. A Carrington-class event happening today would hit a satellite population roughly 10 times larger than existed a decade ago. A power grid running closer to capacity margins than at almost any point in its history. And a GPS-dependent economy that didn't fully exist the last time the sun threw a real punch. That is why astronomers and space weather physicists are watching this declining phase so closely. Not because the numbers are unprecedented, because the target got bigger while the gun stayed exactly the same. And that brings us to the conspiracy angle, because any topic involving the sun, the grid, and words like, and it's worth naming it directly instead of pretending it doesn't exist. Some corners of the internet claim that governments are deliberately underreporting solar activity to avoid panic, or that a coordinated solar-triggered grid collapse is being planned as a pretext for some kind of control event. There is no credible evidence for that, and honestly, the real explanation doesn't need a conspiracy to be alarming. Solar physicists publish their raw data completely in the open. Sunspot counts, flare classifications, and coronal mass ejection speeds are tracked publicly by NOAA's Space Weather Prediction Center and released in near real time, free for anyone to check themselves. The concerning part isn't secrecy. It's that the plain, publicly available data is concerning enough on its own once you understand the infrastructure math sitting underneath it. So what should you actually be watching if you want to track this the way the people who study it do? Number 1. Watch the X-class flares, specifically their frequency during the declining years, not just their raw count. A handful of X-class events have already occurred since the October 2024 peak, and historically, the sharpest, most geo-effective flares of a cycle often cluster in the 2 to 4 years after maximum. Precisely the window we are entering now. Number 2. Watch the KP index. This is the standard measure of geomagnetic disturbance, scaled 0 to 9. A KP of 5 marks a minor storm, usually just aurora a little farther south than normal. A KP of 7 or 8 starts to threaten satellite operations and high-latitude power grids. A KP of 9 is the extreme tier, the Halloween storm and Carrington event territory. It's published live, and it's the single fastest way to know, in real time, whether a storm currently unfolding is a light show or a genuine hazard. Number 3. Watch for coronal mass ejections, specifically flagged as Earth-directed, sometimes called halo CMEs, because of how they appear in solar imagery, expanding outward in a ring, meaning they're heading straight at us rather than off to the side. These are the events that actually matter for infrastructure, far more than flares alone. Number 4. Watch how utilities and satellite operators respond, not just how the media covers it. When you see transmission operators preemptively reducing load or rerouting power, or satellite companies raising orbital altitude ahead of a predicted storm, that's a far more honest signal of real risk than any headline. Connect all 4 of those back to the mechanism we walked through, and you've got a working framework for reading solar storm news the way scientists actually do, instead of the way outlets tend to package it for clicks. Here's where this leaves us, and it's not a comfortable place, but it's an honest one. We are past the visible peak of solar cycle 25. That part is true, And it's not fear-mongering to say the number of sunspots is falling. But the historical record, Cycle 23's Halloween storms, the Carrington event's own timing within its cycle, makes clear that a declining phase is not a safe phase. It's a phase where a tangled, unstable magnetic field can still produce the single worst event of an entire cycle, sometimes years after everyone stopped paying attention. And this time, that event would be landing on a civilization more electrically interconnected, more satellite-dependent, and more timing synchronized than at any point in human history. That's the real story here. Not a sun behaving strangely. A planet that has spent 2 decades building itself into something a strong solar storm can reach in ways it never could before. Watch the flares. Watch the index. Those 2 numbers, tracked honestly and without hype, will tell you more about what's actually coming than any single headline ever will. If this kind of quiet, creeping planetary risk is the kind of thing you want to understand before it becomes a headline instead of after, subscribe, because this is exactly the territory this channel exists to map. Like this video if it changed how you'll read the next solar storm alert that crosses your feed. And share it with the one person you know who still thinks space weather is just about pretty auroras. Because by now, you know it's a lot more than that.